is Nick. Today I will help you to solve your problem. Our topic today is capacity planning and control technique. So, what is capacity planning? Capacity planning is the process of determining the production capacity needed by an organization to meet changing demands for its products. In the context of capacity planning, design capacity is the maximum amount of work that an organization is capable of completing in a given period. Here we describe 4 procedures for capacity planning. Capacity planning using overall factors, CPOF, capacity bill, resource profiles and capacity requirement planning, CRP. So we continue more details in CPOF that have few rules or tips to calculate CPOF. Those rules are MPS as the input, based on standards or historical data for end product, and last overall labor and hour or machine hour capacity requirement estimated. CPOF valid only when the product mixes or historical divisions of workload between work centers remain constant. The advantages of CPOF is ease of calculation and minimal data requirements. And the disadvantages is valid only when the product mixes or historical divisions of workload between work centers remain constant. We proceed how to calculate the CPOF when given the MPS data, work centers with the percentage that run and labor time. Every period has its own end product to achieve required capacity. For the total capacity is the summation of products at the same period by the total direct labor in standard hours. Thus from the total required capacity we get into the work center capacity that can achieve by the total capacity multiplied by the historical percentage given for every work centers. Then the next technique is capacity bills that required more data than CPOF. The MPS data is used to estimate the capacity requirement for every work center. Bill of capacity indicates total standard time to produce 1 unit of end product by work center. Capacity bills more desirable than CPOF, especially for firm experience significant period-to-period product mix variation. Standard setup hour per units are the standard setup hours divided by the number of standard lot size. For example, for end product A, the standard setup hour per units is 1.0 divided by 40 equal to 0.025. Total hours per units are the summation of standard setup hour per unit and the standard runtime per unit. For example, for end product A, the total hours is 0.025 plus 0.025 equal to 0.5. To get the capacity requirements using capacity bills, we have to multiply the MPS quantities with bill of capacity and get the total with summation for every end product for each work center. Then, the other technique is resource profiles, or the other name are bill of resources or product load profile. Production lead time data has to be taken into account to provide time-phased projection of the capacity requirements for individual production facilities. It provides time-phased projections of capacity requirements for individual work centers and more sophisticated approach, but requires tracking of relatively short time periods. Bill of resources, a listing of the required capacity and key resources needed to manufacture 1 unit of a selected, typical, item or family. The resource requirements are further defined by a lead time offset so as to predict the impact of the item, family scheduled on the load of the key resource by time period. The time per unit of each component is based on the information of the total hours per unit from the capacity bill table. Requirement by work center and period for 1 unit of end product are multiplied by the MPS plan to determine capacity requirement. Then these capacity requirements are then summed over all periods to finalize the process. For example, for end product A at period 5, the time-phased capacity at work center 100 is 0.05 times 40 units equal to 2.0 hours. And the last technique is capacity requirement planning that differs from the other 3 techniques before. CRP utilizes time-phased material plan from MRP, takes into account materials and inventory, accounts for the current status of work in process and accounts for service parts and other demand not accounted for in the MPS. Data of detailed MRP that content the plan quantity multiply by processing time for work center. The process repeated for each work center to complete the plan. Thus the conclusion of data requirements for every technique are CPOF, MPS, standard hours of end items, historical workload patterns, capacity bills, MPS, BOM, routing, labor, machine hour for each operation, resource profiles, all of the above plus lead time for component parts and subassembly. CRP, all of the above plus MRP, that is, planned orders, WIP, scheduled receipts. Note, there is an increasing requirement for data from CPOF to CRP. For the general justification, CPOF is more in reduction of cost, ease of preparation and simple, but for resource profiles more complex and get into the accuracy of capacity planning. I hope you enjoyed this video. Thanks for watching.